I will call Vance Mac. Vance?
Hi everyone, I'm Vance Mack. I'm a first-year PhD student from the University of Exeter, and today I'm going to be talking about the responsibility for the conservation of Kittiwake in the North Atlantic. So I'm sure we're all aware that there have been major declines in different populations of seabirds globally. This is no different with black-legged kittiwake. So in the UK alone, we've seen over a 50% decline in the last 33 years, and similar declines are seen across the North Atlantic. One of the key evidence gaps or deficits for black-legged kittiwake concern the non-breeding season. Specifically, management and conservation currently prioritizes the breeding season with the kind of thought that kittiwakes migrate into the greater pelagic high seas areas during the non-breeding season where they're immune from anthropogenic nearshore threats. There's also a deficit in knowledge about meta-population distribution understandings. So for example, sensitivity mapping often only looks at national scales or national populations. Now, some work has been done to look at meta-popular distributions. The landmark paper for this is Frederickson 2011, where they used a multi-colony approach of 19 study colonies and 234 GLS-tracked kittiwakes to examine distributions during the non-breeding season. So we can see the kind of West Atlantic wintering sites off the Newfoundland Labrador area, as well as the eastern wintering sites in the North Sea and Celtic Biscay region. Since that paper was put out, GLS data for kittiwakes have continued to be collected in very large numbers, largely by the Sea-Track project, which is the data that I'm using today, so many gratitude to them. Currently, the database has close to 1,500 kittiwakes, which make up about 3,000 tracks. It covers over 14 years, and tracks come from 10 different countries, which represent 99% of the North Atlantic metapopulation, and about 36 colonies, which represent 25% of the metapopulation. To put this visually, our dark green countries are countries where we have tracking data from, and the green circles are our study colonies themselves. When we overlay our kittiwake fixes, they look like that. So a lot of data over the entire North Atlantic. To use GLS data, it's a little bit complicated in that there is a relatively large error of about 180 kilometers. To address this, we used a 200-kilometer tessellated hexagonal grid, which encompasses this area. And from there, we can kind of generate fixed densities. So this is the fixed densities for the non-breeding season, September through April. To get a comparison to the earlier Frederickson figure, we can take December only and reproject it so we get a kind of comparison. And we can see very similar results where we have that West Atlantic wintering site as well as the East Atlantic one. What Frederickson also does is scale up by population size so they can kind of quantify the amount of kittiwakes at each large marine ecosystem. Initially, we were thinking about replicating that, but we came across this paper, Bila L 2021, which looked at global political responsibility for albatross and large petrel. And what they did here was use EEZ boundaries to quantify the amount of time spent within each EEZ, and as a result, kind of infer the relative responsibilities of the different EEZs, which brings us to responsibility for kittiwake conservation in the North Atlantic. The first step we have to do, however, is convert our raw points into a metapopulation perspective. To do so, I thought we could go through a worked example. So if we wanted to find out how many kittiwakes were in Canada during the non-breeding season, we can take a study colony, for example, Rissa in Norway, with a population of about 9,500 kittiwakes, 135 of which were tracked. On January 3rd, 20 of 135, or about 15%, were within Canadian waters. And if we scale that up, we can estimate about 1,411 kittiwakes from Rissa were in Canada on January 3rd. There are a few other steps to scale up from colony to country size, but we can repeat and sum them for all our colonies going from our 3,000 tracks to the 2 million or so metapopulation in the North Atlantic. And from there, we estimate about 371,000 kittiwakes were in Canada on January 3rd, which is about 18.4% of the world population. We do this for the rest of the days of the non-breeding season, and from there, we can estimate about 75 million kittiwake days were spent in Canada, or about 20.3% of the non-breeding season. We repeat this for all our countries, and we go from our raw points, or raw fixed density, to our corrected fixed density. So you might notice one of the big changes there was the Norway density has kind of gone when we correct the fixed density. And this is largely because Norway has very good coverage and a lot of tracking done on kittiwakes. Good job, Norway. So when we scale for a metapopulation size, this kind of disappears. We can overlay EEZs to kind of see the context in which these kind of grids fall. And when we summarize this, we can see that actually more time was spent within EEZs for the entire non-breeding period as opposed to the high seas. And when we look at only the core wintering, so we try to cut out any migrations that might be late or early, during October to February, the number changes slightly, but still more time is spent within EEZ boundaries rather than the high seas. When we break down our EEZ jurisdictions, we can look at that in panel A on the top. The most time is spent within the high seas, followed by Canada, Greenland, and so on and so forth. We're able to interpret where these kittiwakes originate from. So black represent visiting kittiwakes. The most obvious example is the high seas, where because no kittiwakes breed, all the kittiwakes in the area are visiting kittiwakes, versus something like Russia, where there are not very many visitors that enter Russian waters, so the majority of time is made up by Russian birds. We're able to get a secondary estimate, which is the number of unique individuals out of the 2 million. We can estimate how many individuals visit a country for any length in time. Some interesting things happen here. If we look at Greenland, for example, there are more unique individuals than Canada, despite Canada having double the time spent than Greenland. If we look at our month-to-month breakdown, we can kind of see why this is happening. So in Greenland, we have high time spent, third from the top, high time spent at the beginning and end of the season, whereas in the middle, we get high time spent in high seas in Canada. So it might suggest that Greenland is sort of a transit area where kittiwakes are moving through Greenland from these East Atlantic breeding sites into the high seas in Canada where they winter. To look at kind of the management implications of this, I thought we could walk through an example of the United Kingdom. So during the breeding season, about 10% of the world's populations of kittiwakes breed within the UK. During the wintering period, this drops to about 4%, which is still a significant amount of kittiwakes. If we look at the origins of the kittiwakes, 39% come from the UK. So these are likely birds that are staying within UK waters year-round, they're resident and not migrating to West Atlantic wintering sites, instead using the North Sea and Celtic Biscay regions. The other 61% are birds that come from other territories, and if we break that down, we can see the majority actually come from Svalbard, followed by Ireland, Russia, and so on and so forth. And this number by Svalbard is actually quite significant, because if we look at the second estimate that we used, which is unique individuals, we estimate about 143,000 kittiwakes from Svalbard enter UK waters during this time. And that's over 50% of the Svalbard population, and they only stay for about 30 days of the 178 in the non-breeding period. However, that's still quite a significant number of kittiwakes for a significant amount of time within the UK. So the UK might hold responsibility not only for UK birds, but during the non-breeding season, Svalbard birds as well. Finally, I kind of wanted to, if you looked at the figure from before, on our left-hand side, we have our origins, and on the right-hand side, we have our destination. So these are birds from Svalbard, Ireland, Russia that are feeding into the United Kingdom. And we've produced this estimate for all our different origin countries, and that looks a little bit like this. So this is a Sankey diagram showing the different flows of origin into destination. So again, on the left, you have your origins. On your right, you have your destinations. And the size of the bars represent the populations and the amount of birds that are flowing from left to right. So for example, if you wanted to ask where Iceland birds are going during the non-breeding season, you can see that the main flow goes to the high seas, followed by Canada, followed by Iceland, and finally to Greenland. So we think there's application for this on both ends if you're an origin or a destination. If you're an origin, you can figure out where your birds are going and where they might be affected. And as a destination, you can kind of interpret which birds you might be affecting by the different management decisions you choose within your EEZ. I'm going to leave this up for the question session because I think there's quite a lot of information there. But that brings me to the end of my talk. Thank you very much. Feel free to reach out and contact me.
Okay, so time for questions. One over here.
Hi, thanks for an excellent talk. Thanks for highlighting my earlier work. I had one question because I'm a bit familiar with the way that SeaTrack have produced their maps. So have you used the SeaTrack methods for predicting positions during the periods when you can't estimate them, for instance, during equinox?
Yeah, so SeaTrack has an algorithm, I believe, that can kind of fill in the gaps between the equinox periods. So for GLS devices, you can't take data 15 days of either equinox. I've not used it in this case. We've looked a little bit into it, but we haven't yet used it right here.
Another one?
I was wondering if you'd had a chance to look at whether there was a lot of interannual variation in these patterns.
So that was one of our considerations when we were approaching it, because we're using such a long data set of 14 years. Right now we've treated each day as equivalent, so January 1st in one year is equivalent to January 1st in another. We have come across the issue of interannual variation, repeatability, and that kind of thing. In this paper, we just wanted to give a kind of a general overview of the kind of predicted distributions. So we've not considered that here, but there's literature out there that shows things like high site fidelity for kittiwakes, I believe from Svalbard. So far it seems like there is quite high repeatability, but that is definitely something we're going to look at for later chapters of my PhD.
Okay. So the next one. Thank you so
Thank
much.
you.
Wat zou je zeggen? You want to stay up or no?
Here?
Yeah.
Yeah, that's fine.
Just on that interview and forward, backwards.
Okay, great. Okay, thank you very much. Good morning or afternoon already, I think. And today I will tell you a bit about Sandwich Terns and their migration on behalf of a lot of people. A couple of them are in the room as well. And but first of all, I would like to thank all the ringers and the ring readers as well, because without them, the whole talk would have been half as interesting. So today I will tell you something about the Sandwich Tern, iconic seabird species of Europe. And they breed in Western Europe, but also in the Mediterranean, Black Sea, and the Caspian Sea. And they're well known for their interesting foraging ecology, but also for their migratory habits. And quite a lot of observational studies have been done already. So already in the 1940s, people knew that Sandwich Terns migrated to the Cape of Good Hope and even beyond the corner, as they called it. And most other studies said, well, they travel on the coast and at low altitudes. And this long distance migration obviously made them very attractive to bird ringers. So lots of metal ringers in the 70s and 80s were put on, and you get these really nice distances. But the one thing that was still lacking is information about routes and timing, and also about their migration strategies, because terns seabirds have very different migration strategies, and a couple of examples were already here. And so there was a sort of incentive that we could do some things with that during our sort of regular studies on Sandwich Terns, because in 2010 we started with a big research in the Netherlands on foraging ecology of Sandwich Terns, and we put on loads of colorings. And up to now we have over 5,000 colorings, and about 15% of them are on adults, and 85% on juveniles, and this generates a lot of data of where birds go. And we did a lot of work on foraging ecology, so foraging trips and stuff. And in 2020 we started to think, well, we might want to shift over from a temporary harness that we normally used for the GPS loggers onto a permanent harness, and that yielded quite a lot of data for year-round data of migrating Sandwich Terns. And we started in 2020 with a small pilot study to see if it worked. And in 2021 we did a bigger study, and then disaster happened, of course. So the loggers would have worked for a long time, but almost all of our Sandwich Terns died in 2022. So only 3 of our original sample are still alive, but the loggers have died, so yeah, you can't win. But they yielded quite nice data. First, I'm going to show you a couple of things about the color rings. And if you plot all the sightings of our color rings onto a map, divided by latitude over time, you see that, there's areas where there's no sightings, there's areas with a lot of sightings. But the first thing I want to talk about is this blob in the top left corner, because there's a lot of sightings just after the breeding season north of the colony. So our colonies are the orange lines, and there's a big number of, because there's loads of points on top of each other. So what you see is this is post-breeding dispersal. So chicks and their parents, they stay quite long together. So you can have parents and chicks combinations up until December, January, still together. And the parents take their chicks first to the north. And if you look at the GPS data, that can go both ways. So birds from the Netherlands, they breed where the arrow is, go on the west side of the North Sea to the north, stay in Scotland for a while, and then migrate south. Also the other way around, of course. On the east side of the North Sea, they go all the way up the coast to Denmark. And why they do this? Well, there's a lot of speculation about it, but the parents might take their chicks to more profitable foraging grounds, or they do prospecting trips to other colonies to see if it's better somewhere else. And not only the birds from the Netherlands do this. There's a lot of confirmed breeders from that colony, which is monitored quite intensely on the west coast of France, and they even go to Denmark. So apparently that northern bit of the North Sea is really attractive for sandwich terns. Well, once they have had this post-breeding period, they start moving south, and actually right now, sort of. So in September, most of the sandwich terns migrate south, and the color rings give a very nice picture. So they winter somewhat between the Netherlands and South Africa, and there's lines that you could see on the previous graph as well with lots of sightings. So there's a lot of sightings in West Africa, in Southern Africa, in Namibia and South Africa, and there's lots of sightings in the southern part of Spain. But they go virtually everywhere. So even to Israel, to the Black Sea, we have recoveries, and really around the corner, almost into Mozambique. And these color rings give you an idea of where they go, but they obviously also give you not an idea where they go, because they go where the observers are. So I'll come back to that a little bit later. The GPS data, they give you exactly where they go. And it's roughly the same. So all of our GPS birds wintered between the Canary Islands and South Africa. But the details are really nice. So now you can see the actual migration speed. So not migration speed in migration per day, but literally the speed on a certain moment. So if you compare the two graphs, the left is the one you've already seen. On the right, these are the GPS tracks of the sandwich terns. Couple of things to notice. Sandwich terns fly along the coast, but they do cutoffs as well. So they fly across the Bay of Biscay, across that little bit of sea next to Gibraltar. They cross the Gulf of Guinea, more on the coast on the way down, and more on that side, much more offshore. And they spend the time, around South Africa, and I've plotted all the mid-January locations for all the birds, so that keep that in mind. The mid-January locations are roughly around the Canary Islands until the southern bit of Namibia. Because now we're going back to this slide again, and there's a huge gap you see between 10 degrees north and 20 degrees south. What's there? If you look at that map before, it's coming back later. There's a lot of GPS birds that winter there, and we only have 5 sightings in Ivory Coast and 1 sighting in Angola. The one that saw that in Angola is in the audience, by the way. So are they there? Are they not there? Well, the GPS loggers tell us that they are there. There's at least 5 of our sandwich terns that wintered a substantial part of their winter in Angola, which is a very important site. And to highlight this observer bias a little bit more, I want to pick out one example. And that one example is blue J14, which has been sighted 5 times in the Netherlands. And you see, around about September, it goes south, and it stays a bit in Ghana, or this is Ghana, in Senegal, Ghana, and then Angola for a while, and then it goes to Namibia, and winters in one specific spot where it has been sighted 21 times. And that's what we're gonna see in the next slide. Because in this site, there's one guy, one of my friends, he's living there, and he is retired, very nice character. He's retired, and he spends every day of the year driving around this Ludwig Peninsula, which is about 30 kilometers across, and he's constantly on the lookout for terns. And that gives wonderful data because it's a sort of constant monitoring effort in one specific site in Africa, which is great. So I keep feeding him all kinds of no. Anyway, so and blue J14 likes it there. So is a bit of that peninsula, lots of sighting or lots of GPS points, and you can actually see that this is a picture of Jean-Paul, and he took that picture 14 seconds before that position was taken by the GPS logger. So it's great he has been seen a GPS logger in action. Well, who can tell that in the audience? But anyway, if you plot all his sightings, those are the red lines on the timeline, you see, well, it's present there, and but there are also a couple of gaps in there. And looking at one of those gaps, I had a lot of things in my talk, but I had to kill it yesterday. But looking at one of those gaps, that gap is between 25th of December and the 8th of January. Well, what happens in that period of time? All the Namibians go to the beach for Christmas holiday, and they go and braai and go surfing. So there's no space on the beach, on that beach where the orange is around it, there's no space on that beach for wintering terns. So they move to somewhere else. So all the yellow ones are before Christmas, and after Christmas are all the red dots. And it roosts in a diamond area where no one else can go. So it's amazing how these sightings coincide with the logger data. And the logger data, going back to the picture, you see all those individuals, some go fast, some go slow, some go near, some go far. It opens all kinds of possibilities for studies into migration strategies. So are they going direct? Are they going fly and forage like most of the terns do? Well, blue J14 goes fly and forage because that top one is on the way down. It ends, well, the logger shuts off at 10 at night, and then the next morning it did a circumnavigation of that island, foraging all the time, blah, 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 and then it started moving all the way to the rest of, to the wintering site. While on the way back it was really fast, so 2 nights, 2 days, straight across from Angola to Liberia, constantly flying. And also, why do some birds hop from one side to the other, whilst others stay in one area for the entire winter? It opens lots of possibilities. So, take-home message, large proportions of sandwich terns go north. They do it for prospecting, but also teaching the kids. Sandwich terns do not fear to travel far offshore, and also not across land, because you haven't seen it, but some on the way back went into the Mediterranean, then across to France to the other side. They winter in a large variety of habitats from a large range, and those small-scale movements, they influence the detection rates of colorings and also the conclusions that you draw from your coloring sightings. And that's it. And this is all the birds together, but no time.
So, some questions. Duas aqui.
Hi, thanks a lot for that. That's a really nice citizen science data set. I was wondering, especially with the movements, the pre-migration movements that go north, through citizen science sightings, do you also have information on the molt of the terns?
Yeah, mainly on lots of people take pictures. So especially the head molt you can see quite nicely. because most of the terns that are recorded are obviously sitting on the ground, so any kind of molt in the wings you don't see, but head molt is very nice. And also, molt is very dependent on the fitness of the animal. So you could even sort of estimate, because lots of sandwich terns that are very fit are already molting their head when the chick is not even hatched, whereas others they molt much later in the season, and the young ones they molt even later. So yeah.
Next one.
When you look at the GPS tracks, you can see that all of them are going along the East Atlantic Flyway.
Yeah.
But when you looked at the ring resightings, there was one that went like the other way. Do you think there is a migratory divide that would be possible, but you just didn't track it? Like
which
another
which one
turn?
went the other way?
One of your resightings went along the other way, like the Asian side.
No, that one went into the Mediterranean, spent some time in Israel, and then went back probably. Yeah, but there are sandwich terns. There's one record of a sandwich tern from Estonia that had a GPS logger on, flew into the Caspian Sea, and then onto Eastern Africa, and then back again. So that is a sort of migratory divide, because not all Estonian or Polish or from that region go that way. They also go west.
Okay. Someone?
If there's no more, 10 more seconds. Oh, there's one more question.
Sorry, just a quick question. Do you know if the chick after the juvenile follow the parents also during the migration more in the south, during close to the coastline, African coastline, or they don't follow the parent at all after?
I didn't got your question entirely, but you meant whether chicks and juveniles migrate together?
No,
or
the
juveniles
juvenile
and
with the parent, did they follow the parent after
Yeah.
or not?
Yeah, because we have got one sighting of also in Ludwig, done by this guy, and he saw chick feeding of a sandwich tern with a chick in January in Namibia. So probably that chick followed his parent all the way down for 6 months, and still got fed in Namibia. So they stick together for quite a long time. Yeah.
Okay, thank you.
10 more seconds. For all the Kittiwake people, I'm looking for the ringer of this Kittiwake. I put it here.
You can fix it then. Yeah. Okay. Thank you. That's for details.
Puede ser arriba, pero en la, sí, si quieres, arriba o abajo.
Ok, perfecto.
¿Te quedas abajo?
Sí.
Sí.
Sí. Hello, everybody. Thank you for coming. Today I'm going to talk about pigeon as a new threat to seabirds. I will illustrate this story studying the nesting distribution and the breeding success of bulbous petrel. This is the bulbous petrel. This is a small-sized seabird that nests underground in burrow, crevice, and other holes. According to the Spanish Red Book, it is an endangered species, listed as endangered. Well, as you know, seabirds, particularly petrels, are particularly sensitive to predation by introduced species, and many populations have reduced their breeding range, currently occupying predator-free locations like large sea cliff and marine rocks. And that is the case of bulbous petrel. We studied the nesting distribution by visiting all the potential habitat and the historical colonies on Tenerife. Tenerife is the main island and the most human populated island on the Canary Island. And we visit all the potential locations, including marine rocks and location on the main island. And we found that nest density was higher in predator-free colonies, mainly located on marine rocks, like here. Obviously, there is nothing new under the sun until here. We evaluate how the presence of introduced mammal, like cats and rats, and potential competitor for nest, like the feral pigeon and the Cornish water, shape the nesting distribution of the bulbous petrel. Cat presence was the best predictor of nest density, but the bulbous petrel nest density was not correlated with any of the two potential nest competitors, the feral pigeons and the Cornish water. So why do I say that feral pigeons are a threat for seabirds? Well, we compare petrel and pigeon nests, and we found a very high overlap in the physical characteristic of the nest. Here you can see a scatter plot of principal component analysis. But more importantly, pigeon competition for nests was the most frequent cause of breeding failure, around 7%, followed by rat predation. It's also true that we couldn't identify the causes of all the breeding failure, but 7% of breeding failure because of pigeon competition is still a very high percentage. Feral pigeon densities have increased in many of these marine rocks in parallel to population decline of bulbous petrel. These high densities of feral pigeon on the rocks can lead to vegetation change, as you can see here in these two marine rocks, where one emblematic plant species from the Canary Island, the Canary Island spurge, have completely disappeared from the two rocks just in a few years. But also, the high densities of feral pigeon can lead to transmission of pathogens and disease. And these two factors should be investigated in the future. This is not just a threat for the bulbous petrel. We asked to seabird researchers across the world using Twitter and the World Seabird Union Forum, and we were informed on negative interaction of feral pigeon on other seabird species, on at least 15 species. So our study provides insights into this overlooked impact of feral pigeon on small birds. You can get all the details in this paper. I'm very happy to answer any questions that you may have, even discuss. Thank you very much.
Debs?
So if you stay there, you want to stay up or? Okay. Backward, forward. Forward, backward, sorry.
Hi, my name's Debs Allbrook. I'm studying for a PhD at Exeter University, and I'm studying kittiwakes on oil rigs in the Irish Sea. So there's actually been growing kind of evidence and examples of kittiwakes nesting on artificial structures, particularly oil rigs. Traditionally, maybe oil companies haven't been too open with what they've got nesting on their structures, but it's starting to come out that some of them do have quite a lot of kittiwakes. We're just not sure how long they've been there for. It seems like they might have been there for a number of years. And the reason this is becoming such a big issue is decommissioning. So a lot of the rigs that were built in like the 70s and 80s are now coming to the end of their life. They're not sustainable in terms of financials anymore because the oil is running low. So they need to be decommissioned. There's actually a maritime law which means they can't be left in place. And even though we know now that could be beneficial to many wildlife species, they do have to remove them. So they either repurpose them or they remove them. So as we know that they're providing these great locations for wildlife, this could actually have quite a significant impact across Europe and the greater world. So I think that's why some of the operators are now really keen to learn more about the birds and cooperate with regulators so that they can maybe have permission to remove the platforms. Because kittiwakes are protected, they can't just take them away. So this is providing great opportunities for research. So my study system is a group of oil and gas assets in the Irish Sea, Liverpool Bay area. And they have multiple structures in their company. And a few of them are host to kittiwakes. So since 2022, there's been a partnership between RSK Biosensors and the oil company to count and sort of set up a long-term monitoring of how many kittiwakes are on the assets. So on the main structure where I work, there's 466 pairs, with a further 70, 56, and 30 on some of the satellites. So in total, that's about 622 occupied nests, which is quite a lot. And that's just one platform group. So there's another one really close to where I work, which could have more. We don't know. And then if you think about all the ones in the North Sea, this could be like substantial numbers of kittiwakes, which are not necessarily included in current censuses. So we started with remote camera monitoring. We've got a network of 12 trail cameras, which are maintained during 3 weekly visits. And we're looking at phenologies and foraging trip durations with these. And then we've been doing a GPS tagging project this summer. So we've been using Ornitella GSM tags and PathTrack UHF tags. Sadly, the Ornitellas didn't work for us. They were working on a 3G network, and we think that it just wasn't strong enough. We've tested it with mobile phones, and there is a signal, but it's obviously not strong enough. But the PathTrack UHF tags, we've got 5 back so far, and they've been really giving us some good results. We've got a base station on each platform. We had to colour them bright orange for safety regulations, and we had to go through an inordinate amount of red tape to be allowed to do this in the first place. But we managed to deploy 39 tags on adult kittiwakes between June and August this year, finishing literally just last week. So there's just us catching the kittiwakes, same as you would on a cliff, but actually really easy because they're all sitting along the beams, and they don't tend to go anywhere, so you can catch them relatively easy. We're also doing an additional colour ringing study. So we've got yellow rings with a 3-letter code on the left leg, and on the right leg we've got a platform-specific little colour ring, which we hope, when they decommission the first rig, will be interesting to see the dispersal of the kittiwakes that were on that rig. So, but that will rely on resightings, which I'll get back to in a second. So just some very preliminary results. Looking from the camera data at mean trip duration, it's looking very, very similar to other colonies, such as in Alaska, Northumberland, and Puffin Island, Wales. So it's around 10 or 11 hours, which is probably not surprising at all, but there was theories that potentially they would be closer to their foraging area, so that they would have shorter trips and be able to forage more easily. But this is, as I say, very, very preliminary at the moment. And then, so from our first 5 tags, they've been on around about a month. So the distance travelled from the colony is between about 50 and 133 kilometres. On an average, they're about 15 kilometres away. So we're pleased that we've got a lot of fixes, and it looks like there's some interesting data coming in. So just a quick map of some of the tracks. This bird is going right out and up as far as the Isle of Man. And this one is, yeah, similar. And also, we've seen tracks right to North Wales, so that's going to be Puffin Island, possibly around the Orme as well. And this is actually similar to some of the tracks I've seen from the Manx shearwaters earlier, similar foraging area, which is quite interesting. This one has the names of the platforms, so please don't share this one. But yeah, just shows you the individual points from the 5 tags. Yeah, so there'll be more to come. And finally, so onto the resighting effort. If anybody is working or living in the Liverpool Bay area, I would be really grateful if you did spot any of our kittiwakes to let me know. So it'll be the yellow tag, and then there'll be a different colour on the other leg of a small colour ring. because the success of that side of it will depend upon getting as many resightings as we possibly can. Yeah, so thank you very much.
So the last one, Vegard.
Okay, do you hear me?
This area, please.
Okay.
5 minutes.
5 minutes, yeah. So a few words about the repeatability in northern herring gulls during the winter. I sent in a quite ambitious abstract, so I had to shorten it quite a lot for 5 minutes. So we have a data set of 63 individuals tagged with geolocators for the Sea-Track project. We got 42 individuals that were tracked for more than 1 year, and that allows us to check for repeatability across years. And we deploy these loggers on Iceland, in Norway, and Russia. And the herring gull is well known to have a wide diversity of strategies. It's omnivorous and opportunistic, and it might also change strategies across seasons, across weeks. It's a hard bird to really put into a box. They might scavenge around the fishing vessels and garbage dumps. They might be looking for earthworms in the fields, but also actually catch some marine fish by themselves. And so looking for strategies, we have the data from the first tracking non-breeding season, November to February, for different populations. And we have colonies from Iceland. They are not going really far away from the breeding sites. We have southern Norwegian populations that are a bit more interesting in terms of variability. Some are going further away from the colony. We have a small data set, 2 birds from the Norwegian Sea, which are staying in proximity to their breeding areas. But then we have these northern Norwegian populations and the Russian population that are going really far and traveling different migration routes. And they are pretty different from the others. 80% of the locations are 300 kilometers away from the breeding sites, while the opposite pattern is true for the rest of the populations further south. Looking into other strategies, we have how much they stay in the vicinity to saltwater, the marine affinity. So for this presentation, just pile them into 2 groups. A marine strategy, where they stay a lot in touch with saltwater through the day on average. And a more mixed strategy, where some individuals may stay almost terrestrial through the whole non-breeding season, or they might switch strategies or be perhaps marine, but we can't really tell. And from here we see that the birds from Russia and the northern Norwegian colonies in the Barents Sea, they are really, most of them are marine, while the Russian birds are more diverse. They might be, have a more mixed strategies. But most of the northern Norwegian birds are full marine all through the non-breeding season, during their first year of tracking. Iceland, more of mixed strategies, not so high affinity for the saltwater. We had these 2 individuals, not so clear picture of what they're doing, but they are probably staying a lot of time in saltwater. And then we have the southern Norwegian populations that have also a very high variability, but a lot of them are in this mixed group. And then last, we have this 3rd strategy that we can look into. How many times the birds pick up light signals during the night. And that is an indicator of approaching human sources of light. So here you have a lot of dots, wet encounters, while the logger was wet and picked up these light signals during the nighttime, and these dry encounters. And in northern Norway, you have a lot of concentration of these points, and a lot of them are also wet. Further south, you also got quite a bit, but more dry values. And on Iceland, hardly any. I can't explain why. It's a decent sample size from those populations. When we look at these strategies across multiple non-breeding seasons, the repeatability, and compare the movements between years, we see that they mostly visit their previous route from the previous year, but timing differs. And if you remove all the individuals that are staying in the proximity of their colony through the non-breeding season, you still get this very nice pattern of birds revisiting their previous year's track. But there are exceptions, and there are birds that are doing the same thing for 3 years and then switches. So there's a lot more to look into behind those data. And saltwater, they do have a sort of approximate repeatability. They do stay in touch with saltwater if they did it also the previous year. And there are no changes from one extreme to another. A terrestrial bird wouldn't suddenly become marine the next year, but it's more versatile and very high variability in those data. And for those individuals that approach light at night, you have a lot of high repeatability. It's clear strategies that some birds are targeting human sources of light repeatedly over years and within the same season. So take-home message is a modest to high degree of repeatability. I could speak a lot more about this, but I will be for another time. So thanks to our partners and for